Good morning. Good evening. This is Mostafa Khalil at VMWARE. This presentation is about VMWARE vSAN. We have a few slides and quite a bit of demos. The demo is based on vSAN 6.5, which is also shipped since 6.0, and all the enhancements that were included in 6.0 update 2, and a few more features. I can take questions along the way. If you have any questions, please interrupt. We had originally allocated 2 hours for this session, a little longer if needed, if you have the time, or if you're earlier, you can stop at that time. The session is being recorded and will be made available for online streaming load on the VMUG webpage where you signed up for this session.
Okay.
So vSAN provides significant improvements on the storage area. This capacity have continued to decline over the years, and the concept of hyper-converged infrastructure has emerged a few years ago and continues to grow. The growth in software-defined storage, in this slide, I'm not going to go over the details of that. Just to show you the difference in growth between the various types of storage. On the right-hand side, we have the enterprise server vSAN storage, and in the middle, we have the traditional enterprise storage, and on the top right, in light green, is the hyperscale server vSAN storage. The converged infrastructure storage is simply a collection of low-patch disks to the ESI or other hypervisors that provide access to a stretched or a distributed single data store. You up, we can scale out in the vSAN storage or ESI in general. You scale by adding additional disks to each node in the cluster, or scaling by adding additional nodes to the cluster with their attached disks. And you have the set of ESXi hosts with the attached disk. They can be hybrid or flash. Hybrid means that there is an SSD cache tier on each host, and there are magnetic disks that has capacity tier. I will details later in the demo. And the form cluster, and there's a single vSAN data store on which all the virtual machines are installed, and they run on the same hosts that participate in the cluster. You can add hosts to the cluster without local storage that are referred to as non-contributing nodes. You still consume a license, including a vSAN license. So it always makes sense that all hosts would contribute storage if at all possible, so you can out while just carrying the cluster. The use cases for vSAN is large, pretty wide. Started as a data store for visual desktop infrastructure or user computing. Was optimized for that type of workload, but it has been enhanced and improved to cover a wide variety of workloads. You can use it, you can use it in staging, you can use it in remote office, branch office, referred to as robo. You can use it for management, you can use it for DR, which is data disaster recovery and availability. in the DMZ environment, and you can use it for business critical apps. It has been tested for majority of business critical apps like Microsoft SQL Server, Microsoft Exchange, and others, including Oracle RAC. Most run mainstream business critical applications in their environments. Variety of applications. The highest number of business critical applications, used are business critical app, flight test and dev, management infrastructure, and so on. A hardware solution that VMware and EMC Dell shipped as a joint solution is called VxRail, and this provides a 4-node cluster or larger, depending on order it, installed with vSAN and vSphere, pre-configured, and it has a web-based configuration and management interface for the appliance into the vSphere management interface. There are nodes, which are nodes that have been certified for vSAN. vSAN really means that you buy them on the listing on the VMware HCL or VMware Compatibility Guide that states the actual combination of a given server, storage, and additional hardware components. You can buy the specific SKU that's referenced by the vendor that certified it, and it's pre-installed with the software. Or you can buy just the hardware and you install the software yourself and configure it. Devices is shifting significantly, and the cost per gigabyte of storage increases by the technology or the type of storage that you use. The lower, of course, is the magnetic disk, followed the solid-state drives, and recently is the non-volatile memory express, which was NVMe, and highest at this point is dynamic RAM. Movement in the production and the cost reduction, you get higher IOPS per device if you move from magnetic disk and shift to non-moving components like SSD, NVMe, and DRAM. Technology that's in the pipeline is called NVDIMM, which is non-volatile DIMM, that will also be supported by vSAN. And supports the next generation hardware as of 6.5, and those in previous chart were NVMe and NVDIMM. I think configuration of NVDIMM yet is planned for a future release. It's really about simplicity. The ON architecture is you have a number of hosts, minimum 3 in the server. Then a robo configuration where you can have minimum 2 nodes in a cluster. A virtual machine. The virtual machine has a home directory which we store the VMX file, VMDK files, and all other files related to the virtual machine like the file and others. We store those on the vSAN data store in the form of objects, and these are divided into components The addition of these objects and components on the vSAN data store uses the object store, which is an open standard called Object Store File System. And we have VMware acquired a company called Versto a few years ago, and we're using that for the actual data storage on the individual capacity and cache tiers. This here shows that you have a virtual disk that is configured as a RAID 1 and it's subdivided to RAID 0, so the combination of 1 and 0 is RAID 10. So one creates a mirror, one on each node in a cluster, on two nodes in a cluster, and each component is divided into further stripes that for RAID 0. Let me show this in my environment. So environment here, I have an 8-node cluster, 6-node cluster, vSAN 6.5. I have created a virtual machine. And this virtual machine has multiple virtual disks. Let me show you the configuration. This is the system disk, where I installed the operating system, and it is 40 gigs in size. And using the virtual SAN default storage policy, I will go over storage policies in a few minutes. The policy is RAID 1, which is just a mirror. Disk is using a RAID 10. It is in size. So let me see how that second hard disk looks like regarding object distribution. Show you how it looks. So here where you would see all the data in the virtual machine and associated storage policies. And here that shows the compliance status. Compliance means that the objects of the machine meet storage policy requirements. Which means if it's a mirror, it means that both mirrors or RAID 1, both mirrors are available. None of them are missing or have enough disks to store the objects that meet this policy requirement. So you can go to the virtual machine and the Module tab and policies where you see the list of objects. One folder is object by itself, which is more analogous to a VMFS data store, because this folder as object is formatted with VMFS format. They have to retrofit vSAN with a different file system to migrate virtual machines from one type of data store to vSAN or out of vSAN to any other type of data stores. So at the RAID 10 virtual disk, there's a RAID 10 policy. In the bottom you would see the definition of these objects components. On the you have the RAID 1 definition, which has two mirrors. This mirror and that mirror, and each further subdivided into stripes. So this has three stripes in each, which in combination makes the RAID 10. When you see placement, you will see that each of RAID 0 are on the same host, one mirror, but on the mirror, notice that we have two of the components, or two of the stripes on one host and the other on a second host. It doesn't matter where they are placed as long as they are not on the same disk. When you strive for performance, not capacity, but you need to have the multiple capacities then read and write from. By the way, this configuration is all flash. Without configuration, the cache is write buffer only, and if it's written on it, is used for read cache. But as the rest of the reads, they come directly from the capacity disks. They are all flash as well. So there is no read penalty. There's no need to fit the cache, the blocks from the individual capacity disks onto the cache tier, which is the way we usually do it with hybrid configuration. So hybrid configuration, the cache tier for write buffer and read cache, and we do not read from the capacity tier directly. If the cache miss, we fetch the block from corresponding capacity tier and copy it to the cache disk on the hardware that capacity tier is located, and distributed cache provides a view of the store and the objects that are in cache. In multi-class configuration, we to do that because again, the cache tier is used for write buffer, read cache for what's on it already. The rest of the is not in the cache. We read them directly from the corresponding capacities. Only for error, we only need to read it from one mirror only. We don't need to read it from both. So it makes the process a lot faster for read and write. At the read one only, you will set, let me go to this one here, the default policy. This is using read one by default. Here is when you see the two mirrors, one on host 3 and one on host 6, with a third component here called the witness. A witness component is required as a ticker in that there is a split brain when the network connectivity between these two hosts is able to communicate with the other where the separate mirror component is located. And a virtual machine is still accessible over the virtual machine network because it's possible that you lose the connectivity over the vSAN network only. We need to know which component we're going to use for read and write. The witness node, or the sitting on this node on the host 4, if host 4 and host 3 communicate, host 6 in this example is isolated or is partitioned, network partitioned. So a combination of the components on the two that are communicating with a majority, because those has what we refer to as a vote. And as long as the network partition has more than 50% of the votes, the partition wins, and that's the one that becomes writable, read and write. And the other node, we read and write from, and after connectivity is restored, we're going to replicate the changes that fit in to the writable partition back to the component that came back into the cluster after the connectivity is restored. When you get to RAID, RAID 1, even though it's defined as RAID 1, it's some stripes underneath. This is not a RAID 10 it is RAID 1, but the reason for striping is that the app size is 255 gigs. Carl, looking at the config here, and at this usual hardware, look at the virtual disks. You will see that I have a 300 gig virtual disk, which is this hard disk number 5. And because the size of the virtual disk is larger than 255 gigs, it has divided the object into multiples that count to 255. So we're going to create two sticks of 150 gig each to be able to meet the capacity requirements. So we're doing the striping here for capacity purpose, not for performance. That we're not bound by having to store this on different, but they are available disks. We put them on separate disks. Cluster is fairly empty. All I have in it is this one VM, and that's why I have one stripe of that RAID 1 mirror on host 6 and 3, and the other two stripes for the other mirror are on host 4. We need disks. Let me see here to the capacity disks. This disk, if I resize this column, you will see that I have disk on target 3 and disk on target 1, and here's on target 3 and disk on target 1. These two on one host, and these disks on two separate hosts. We have land on the same disk on the host for a given mirror, because I don't have to enforce the performance requirement. We have to split the components over multiple disks for the RAID 10 type configuration. Since this one is not actually a RAID 10, it's a one, but we have to stripe it to meet the capacity requirement. It does adhere the performance placement requirement. So far?
I have one question.
Yes.
Okay. Regarding the next generation of vSAN, now we can remove the magnetic disks for capacity and put SD as a capacity storage.
Yes, it's called all flash.
Yes. To storage appliances, we apply all flash.
Yes.
Another thing, the issue of caching devices in vSAN is still 10% of total size of capacity.
Ratio of the cache tier to capacity tier, the rule of thumb is 10%, but it's an absolute rule. This is just a general guideline. It depends on how many objects need to be cached. If you have, for example, a RAID, let's say 10, so for RAID 1 means that you have a mirror. So cache half of that, which is one mirror only, because we don't need to cache both mirrors. So if it's, say, 1 terabyte, we're going to cache half of that, which is 500 gigs. Capacity for calculations of the cache tier, you need to have this total data store is 10 terabytes. If you get the percent guide, you would need to have the cache is 1 terabyte. But we have limitation on the cache of 600 gigs because the way SSD works, we want to consume the whole SSD because there's a process of rotating the cells that are unused to avoid the SD being consumed too soon, because the SSDs have a lifespan based on the number of writes per day, the amount of written to it per day, or called DWDM.
Yeah, that's now. I don't know. Also, I think the factor of using the percentage cache, it depends on also about regard hit rate. How to increase hit rate?
Okay, cache hit rate, it doesn't really matter because with all flash, we do not use the cache tier for read. We use mainly for write. We can read from the capacity tiers directly if there is a cache miss. There is no penalty for a cache miss on all flash configuration. Only applies to a hybrid configuration. The hybrid, we have to fetch the cache miss and from the capacity tier magnetic disk, and then copy it to the cache tier before we provide the reads and the writes.
Which means we have two scenarios. If we use all cache, we depend only write, not cache. If we use a hybrid scenario, we'll use either read or write cache. And this scenario, we will face misaddress.
So again, to rephrase what you stated, for that configuration, the cache here is used for write buffer and for read cache. Not use the magnetic disk for read at all. Buffer, we write to the cache tier, so we have a need to free up some space on cache tier because we had some cache miss. We have to stage some of the least read block cache to capacity tier, then and have space made available for read or copying the cache miss from the magnetic tier to the cache tier. There is a 70-30 ratio, 70 read and 30% write by default for the hybrid configuration. For the flash, it's a 100% write buffer, and what's written in the buffer is used for read, but what's not in the buffer is read directly from the SSD capacity tier. The cache miss applies to hybrid configuration.
Okay, got that. Thank you.
And if you have a high rate of cache miss, then we need to clear your in multiple disk groups where you can have additional caches added to each node. So you set your disks over multiple disk groups, and each disk group have a SSD cache and number of magnetic disks. This gives you a larger number of caches where you have less frequent having to destage the data from the cache to free up read cache.
Okay. Thank you.
Okay. So the example of the RAID 10 that I was showing you is represented here in this diagram. We have the RAID 1 definition has two mirrors, and each mirror is subdivided into a RAID 0 stripes. This picture. at the RAID 1 configuration, you will see that witness component that I mentioned. But when you look at this RAID 10, you don't see this. So what happens if there is a network partition where all these components on one host, host 4, is component on 2, 3, and 6. Host 4 loses network connectivity to cluster. Where should we write? Should we write all the and read from the stripes on host 4 or on host 3 and 6? The witness is substituted in this case with a property in each component. It's called N votes, or number of votes. And one of these components would have more number of votes compared to the rest, and the network partition that has the components with the higher number of votes, when added with the rest of the components, it make up more than 50% of the votes compared to the other partition, that partition that wins, and the one that has read and write. How can you tell which components has a higher number of votes? This is some under the hood look into the actual vSAN metadata. It's a fairly advanced concept using the command line. We don't usually prefer to have customers do that. But we'll share this with you, which I also share in my upcoming book that's coming up hopefully next quarter, implementation of vSphere 6, that includes chapters about vSAN, would have all under the hood type of details. So we put this on, so I'm still on speaker. So if I switch to an SH session, this color visible to you on the screen and the font is large enough? That it's a yes. Okay, to see that, please let me know and I can change it. Okay, so I'm into this host. This host is node 3, which is this one. And on node 3 is host. The ESXi host has on it this data store, which is its portion, actually the view of the data store from the cluster. So we look in surface volumes and data store, you will see the extent of that data. And then you see this book VM, which is the virtual machine that I created. If I rerun this command with so I can see the extended details of the output, you have this VM link this directory. This has a long hexadecimal name. This actually, we refer to this as the vSAN UUI, Universal identifier of this directory of the virtual machine. Remember looking at the UI here, when you look at VM and you look at this, the objects, you will see that in home folder, the VM folder is represented by this folder here. And the folder is actually an object that's stored on vSAN with this directory ID. So to that directory, I have in that I have the VMDKs, and the VM is powered on, there's the swap file, a set of log files, LCK. The VMDK files, normally in a standard VM data store, you need a second file for each VMDK that is referred to as the flat file. And instead of a flat file, we have an actual object that's stored on the vSAN data store. And how to know which object belongs to which VMDK file? You simply look at the content of that VMDK file. And in this case, let's look at this one here. And then you will see a section that's called extent description. In the VMFS data store VMDK file, you see in the extent here, you'll see the reference to the flat file or other type of file. When that reference to this extent is a prefix of vSAN : // This format is referred to as Universal Resource Indicator, or URI. And by this object, the object that represents this VMDK in the vSAN data store. So you copy this object, and you use the CMMDS tool. By the way, vSAN has several software components. Here I can share with you a sneak peek at my book. Let me open this and show you something quickly here first on the software components that are included as part of vSAN. A little. Can you see the diagram? Yes. Okay. So this a component called Cluster Management Membership, or CMMDS, with another component, a software component called Cluster Log Object Manager. Cluster Manager. And that one, a distributed object manager that was referred to as DOM. And DOM has something called LSOM, which is Log Structured Object Manager. These are logs. The logs are stored on the cache tier. It has a list of tables that reference the objects and the corresponding components. When they are destaged, gets written moved from the cache tier to the capacity tier. And the DOM communicates with DOM on the other node. The vSAN network, use the VMWARE, what we refer to as reliable data transfer, that communicates with all nodes. So to have the vSAN network for vSAN cluster to form, and vSAN 6.5, you wire this network to be multicast network. We're planning to support unicast network in an upcoming release. It's in beta. CMMDS is the actual database that has in it a database that holds all information about every single component in a vSAN data store, whether or not they are related to VAs or other types. So if you need to look up an object property or a component property, you need to look in the CMMDS database. So if you, this tool here, the CMMDS tool, is the tool that allows us to create this database that's created by CMMDS. This is available as a read, write on one of the nodes that's referred to as a master node. Then there is one back node that if the master node becomes unavailable, the network disconnects or the host is down, this back node takes over. It has a copy of that database. And then the rest of the nodes are referred to as agents. And how can you tell which node is which? Excuse me. This node here, node 3, you can ESX CLI cluster get. You see that this is a state of agent. Means the read-write database is not on it, it's on another node. Excuse me. And bottom here you see that the subcluster UIDs, these are the number of nodes that make up the cluster. So, excuse me. Let me cast VMDK again to get the UID. You can run CMDS tool, and then it's find in a database something. You can use a different format, use the JSON format to have separation of the fields. And then the UID, we use -u in the UID. This is a set of text. This one is referred to as the DOM object. That is the object definition. And when the object has a content, it has multiple fields. Here for the end vote, so let's type this to less, then lower vote, or it's a B. You hear that I have one has 2 votes, it has 2 votes, third one has 2 votes. Okay. What does it mean? So the object has multiple components. When you use the components, you will see there is a child 1, in the server. This object, this field, and subdivided. This one is no. Okay, know that this is way advanced, but I just with end vote down here are subdivided for readability. So here there is a rate 1, and 1 has a child of 0 or multiple children. Each of rate 0 components is divided into the stripes. The rate 0, I have child 1, this is the first stripe. When you scroll here, you see vote listed here. This has 1 vote. If invote is explicitly specified, it means it's a single vote. Here's the stripe. Invote here. Here's stripe of rate 10, or rate 0, child of rate 1. The second replica, you will see here that rate 0 has the first one, here's one, and here's one. In this example, there are no inputs assigned to individual components, because the witness is the tiebreaker. If, in my example here, since I don't have a witness, I have inputs. So the children here, I have this rate 1 has this rate 0 child, and 0 child has a rate, the striped children, where I have this child 1 is 1 stripe. And you see it here, it says invote is 2, and child. The second stripe, there is vote in it. I have the rate 1 that it has 2 children at rate 0, rate 1, rate 0. It has children, child 1, that's 2, and 2 has invotes 2, which means that this has votes, one replica has 2 votes. In this example here, yes?
Now the screen is not it's not the big.
Switch to okay, I lost the share. Let me share my screen. I'm sorry.
Okay. I think someone share
the whiteboard. Yeah. Okay. All right. So let me go back again. So in this output here, go back to the see. Were you able to see the snippet from my book? This. All right, so they haven't seen it, so let me repeat that again. This text, this thing here, that referred to as the DOM object. The kind of the DOM object has these details, and align them that way. So you separate the fields and their related subfields. The rate configuration has 2 mirrors, which are referred to as child 1, that's rate replica, and now child 2, that's the second rate replica. And each rate 1, you have the rate 0, so the rate 0 definition, you have child 1, 2, and 3. These are 3 stripes under the rate 0 child of the rate 1, which makes up the rate 10. When the second mirror, or the second same structure. Here is the one definition, and that definition, that's the child of the one three stripes. Stripe of the rate 0, and child 2 of 0, which is this one here, and the rate 0. You note in this output there is no in votes because there is an associated witness. See in votes when there is no witness involved. And the votes work. Look at this example here. This is from a different risk from the have in the screenshot in the book. You would say that this is the beginning of the content. You have the configuration, and then you look for the rate 1. Here's 1, and that has a child of rate 0, which to this view here. To that rate 10. You have one has rate 0 and a rate 0, and each rate 0 has 3 components. So these are the children of that rate 0. Rate 0 here is that I'm looking at that says type rate 0. It has 3 children. Here's child 1, and there's child 2, and child 3. We see this one is the, not this, is this one here, little children. This child of the rate 0 has an N vote of 2, child state an in vote, which means that this is a single vote. Second, 0 here has children. Child here has 2 votes, and child 2 here has 2 votes, which means that these 2 stripes have 4 votes, and these stripes have 3 votes, which means that set of stripes here, 4 votes than these stripes, which means if I lose network connectivity between host 4 and 3, if host 3 can talk to each other, and that's one that remains as read-write, and we stop writing to reading from stripes on host 6 and 3. These 2 stripes have a majority of the votes. We put the split brain. If there is this inherent number of votes associated with each component, if the partition that has the majority of the votes, which is more than 50%, that's the wins. Concept? So how do we create those policies? So take you this here. You can do this hands-on if you have an environment Log into the VMware hands-on lab. And after you log in, go to the focus is storage on the left-hand side. And here you have that version 6.2, and then you have this vSAN challenge lab. Using the top, it has all components that you need to practice on virtual SAN. Timed lab, but you can repeat it at time. You can time, and eventually when you run out of time, you can subscribe to it again, start over. So to my assignment here. So this is similar to the hands-on lab. Like this. Create a policy. You start from the home page in the vSphere client, and then you have here VM policies. And to policy, you click on Create a VM storage policy. And mark. This is one. To rule set 1. This is a feature. If you use any object SPBM, storage policy-based management, with other storage features in vSphere in the past, like VASA, you had to create a rule to utilize the VASA provider. In here, example, I have one VASA provider. That's if your VASA providers like for virtual volumes or for standard VASA 1.0, you see their providers are listed in this list. You select the VASA provider. This rule would have information specific to this. They're provided by this provider. And you have these rules. You have failure to tolerate. If you means that you lose one host and the data becomes available, means that you need to have 3 hosts minimum. If you lose one host, you still have 2 hosts left. We can recover on the missing host by replicating from the survive and replica on one host onto the other 2 hosts that didn't have it. If you want more than number of failures to tolerate, then you set this value to higher than 1. You can FTT equals 3 in 6.x. With up to 3, let me see here. If you click on here, online help here, you will see the values. And the number of hosts that you need, depending on what you have in combination with the failure to tolerate. So the older way of doing it, which is using number it equals 1 means that we're going to have a copy of each object, means replica. And here on the left-hand side, it tells you that for 100 gig, you need 200 gigs of space, because we're going to need to replicate that to this capacity requirement. If I change this to 2, it changes of 2. That changes that for 100 gig disk, you need 300 gig space. baud capacity of the vSAN doesn't necessarily mean that it's all consumable for equal amount of capacity for data. You have data consumption used for the protection provided by the specific rule. Set this back to 1. And if this the way it is, I'm particularly creating a RAID 1 because I'm a mirror. To create a RAID 1, if you use this here, you can in vSAN 6.2, which is update 2, and vSAN 6.5, then there's called failure message. And here you have two choices, a RAID 1 or /6 with erasure coding. It says here gives you performance because it's sitting over two separate sets of mirrors. If you RAID 5, this for capacity, then you have RAID 5 or RAID 6 split across set nodes in a cluster and a parity on another node within a few minutes. You leave this as RAID 1 mirroring and you continue with the rule set creation. Just go on next. The available storage that's compatible in this case is vSAN data store. Next, you click on finish. It will create that rule policy. So would you create a RAID 5? You here, say this RAID 5. Here, because I'm going over. Now, the vSAN provider, and then I select the tolerance method. And here I need to, before I select a RAID, if it's RAID 5 and 6 here, can I tell the difference between 5 and 6? And another rule, which is the number is tolerate. Of this field and this field will dictate whether it's RAID 5 or 6. If he's number failure tolerate or FTT equals 1 with the famous method of RAID 5/6, this is a RAID 5, which means you have a RAID 5 with a single parity. If you want to do a RAID 6, you need to set this to 2, which is a RAID with 2 parity. So that's a RAID 6. This is that. Do the RAID 5 first. Or let me do this as a RAID 6. I'll rename it. Go back here because I already have a RAID 5 defined. So if I this here, you look here on the right-hand side, you see the calculation changes. For 100 gig, you need 50 gig space. Compare that to a RAID 1, you need 200 gigs. So it saves you on space, but at the expense of performance. In RAID 1, you double the space, but you gain performance. So the RAID 5, this is the RAID 6. With the RAID 5, you need 133. So it takes 1/3 of capacity to RAID 5. That saves you 2/3 of the capacity compared to a RAID 1. And 6 will yield 50% more, which means that you're saving 50% of capacity, additional capacity, compared to RAID 1. Let me exit this one here. I'm going to run one here. Let me switch to out of full screen. Okay. And back to my lab. So here I have defined a RAID 5 and a RAID 6. So with the RAID 5 distribution here, you see that I have 1, 2, 3, 4 components. There are these stripes and parity. But are these actually the stripes and the parity? No. You would think this, that each component, you see it sitting on a separate host. So it's similar to a physical disk in the RAID 5 disk array. Stripe the data across these components. Simple. I have it in my book. I'll give it to Let me zoom here. So you have 4 components, one on each host. And then each component we write in is of the RAID. A stripe goes across all components. Every time I write the RAID, I'm writing in these set of stripes. So I have the stripes spread over each node as data, and the fourth one is a parity. And the parity on the same host all the time, they are spread over different hosts. The stripe here, I have the parity data. This is the stripe. And down I have data, and then parity, and then data, and so on. So if I use this host, I have for this stripe here, I'm going to create parity on the new host that I'm going to add for recovery. For this stripe here, I love data stripe, a block, but a parity with 2 remaining data blocks. From the parity and the data blocks, I can calculate the missing data block, and I create it on the recovery host. So, example, I have 4-node cluster. If I have a 5-node cluster and I lose one host, the remaining hosts automatically take over for recovery, and all the missing components here will get recreated on that host by calculation of parity and the remaining data. For the RAID 6, you need more. Let me see here. It's a RAID 6. I don't have the diagram handy at this point. So anyway, RAID 6 will be similar to, let me look for it. I need the diagram here. RAID 6. What I would have minimum 6 hosts where striping with 2 parities. So you have 4 data blocks and 2 parities with 2 hosts, and I rebuild the data from the surviving hosts. So use the hosts, use from I have 1, 2, 3, 4 data blocks. I kept the parity on 2 other hosts. Here, 1, 2, 3 data blocks, and 1 parity and 1 data block. I mean, the data still survives with a parity. I can create a parity data block on 2 other host recovery by using the parity to create that data block and create a second parity. Notice that each of those components have a number of votes. This votes, 1 vote, 1 vote, 1 vote, 1 vote, 1 vote. That's what I showed you for the RAID 10, which means that if I network partitioning, the components with the majority votes would win, and here we're going to start using the available parity to recover. But still have no more hosts listed for the data to be available. 2 parities here, but no more. So no partitioning of these 2 hosts, I have access to the data. Any questions? Okay. So here's RAID 6. They have 6 components, which is set to hosts with components, and we're mapping the data across each of these components. And by the way, those in 4K blocks. Excuse me. How about the network configuration for vSAN? 10 includes a license for the license of vSAN automatically gives you a license for distributed switch. And 5, you also get a license for all flash. A special license for vSAN to get all flash support. The network is configured that way. If you go here to a distributed switch, you create a distributed switch like this, and manage network on distributed switch is that you right-click and you select Add and Manage Hosts. And I already have this configured. I'm going to manage host. If this is a new distributed switch, you select Add Host. When you next, you get a chance to select from the existing host to add to that distributed switch. When I click Host Networking, the next select the attached host. You see that host state is connected or not connected or not responding. So these are available in this center, whether connected to the distributed switch based on that column. So I manage all these hosts that are currently connected It's physical adapters, which are the uplinks, and VM connectors. Adapters is where you specify which VM, which are the uplinks, are assigned to each host for that distributed switch. And here I have this host, which is has one VM NIC, but these hosts have two VM NICs. This mode, if you want in maintenance mode or not, but I'm saying this host is in maintenance mode because I'm not using it in this cluster. But if you have a second uplink to that host on the distributed switch, you select that NIC and then assign uplink and the uplink number, assign, and the VMK nickname later. Is called VMNIC 2 compared to 1. Again, this is the NIC with the uplink. Configure the VMO ports or group. The VMO port has a VMK name, which refers to VMK. So each of the VMKs needs on this second host. This VM here, if you adapter, make sure you have virtual SAN selected. I use both vMOS and vSAN. It's not a best practice, but because I have a limited number of VMK NICs that I want to configure. So if it's selected, checked here in this VMK NIC, you will not have a vSAN network configured. You need that in this one screen for each host, you have one VMK that is configured. And here on the right-hand side, you will see the port group that is associated with each VMK. In the port group, vSAN-DPG port group. For me, make a difference. Okay. And they're done with all the VMK NICs, and make of them have the vSAN. You can click next and the review, and you click on next, and you click on finish. And monitor the progress here in the vision task. Just need to configure the network in one place instead of keeping hopping around to each separate host. Now I go back to the cluster here. Excuse me. I want to show how the vSAN provider or provider is registered, or where is it registered? This is the vSAN level. Here in 6.5, in 3.5 it's called configuration. You have a storage provider in the bottom, and you would have lists listed here. You sort by the name to make it clear, because in 6.5 we introduced I/O filters where you can't use it for virtual machine encryption. So if I did this thing here, I have the vSAN listed on the top. Each host has a provider registered with V, and each provider has an active a state, whether it's standby or active, priority with a value. Remember, I told you that one host is a master, another host is a backup, and the hosts are agents MDS purpose membership. One is active, one is standby. The active passive is on the node, and the step passive provider is on the backup node. The rest of the passive providers are standby, but they have less priority. How you can tell? You can tell for the standby passive providers which of them is the backup, which of them are the agents. So it has the highest priority, the passive provider, and the spy of the backup has the second highest priority, and the remaining standby have 4 priorities. Is there a question?
No.
Okay. All right. So when you select the data store that this under this host, you see the vSAN data store ID, and you see, and it says the capability, the profile is the storage object profile. To vVols, you're going to see the vVol with also storage object providers, but it's going to say vVol virtual volumes. The actual host, you will see additional details. Where you have the similar columns that you see here, and here you see the provider ID. Each host has its own provider pre-installed with ESXi when you install it, but it registered, then you create the vSAN cluster. So the process that you would to pick a vSAN cluster, you first create the cluster and license it, and then host to the cluster, and back to the cluster, and you configuration, you go to configure, and select under the section, you select general, and you select edit, and you enable vSAN and turn it on. And 6. Update 2, which is referred to as vSAN 6.2, we introduced the dedupe and edition requires on-disk format version 3. Means that when you grade from 5.5, it has version 1, and 6.0 has 2, 6.1 has version 2. It will update when you get to 6.2 or 6.5 is going through a rolling upgrade of migrate data off of this group to this group, recreate it with the new on-disk format, which is version 8. But in 2 and 6.5, there is an interim version that's referred to as 2.5. Actually, the 2.5 is on this version 3, and version 3 in the UI is on this version 4. That's why it's released as in beta right now. We have on this version 5. We're skipping 4 in the UI. We're syncing up the UI with the on-disk format. Able to you select the dedupe option here through the process of updating if you haven't upgraded the data store to on the format 3 yet. And if you do, it's going to enable dedupe on the version 3 of this group. It's a property that gets added to the group configuration. So what we see the dedupe. When you look down here, and the opacity, the VN button here, 2 seconds here to refresh. see the statistics of dedupe. On the top-hand side here, you see deduplication and compression overview. It shows you it's used before with 2.32 terabytes. This after is 26 gigabytes. That's 10-fold ratio, which is the ratio of compression and dedupe of 1 to 10. The savings is 90%. Down you would see that dedupe compression overhead. This is a fixed percent of the total vSAN data store capacity. Sum is overhead. I think it's a 1%. Sorry, 1%. I don't remember exactly, but I have written it in the book. To have deduplication enabled, you need to make sure that you have enough free space because to require remove this group one at a time and recreate it, and to do that, it has to vacate the disk group. If you not, or if you don't have free space, typically you turn dedupe when you start running low on this space. You just install the updated license to trigger dedupe. The trick is that when you create dedupe, when you enable dedupe, it enables you to vacate to the configuration screen. When you dedupe, the checkbox in the bottom here that says allow reduced redundancy. This means that you will be taking a risk of upgrading or you enable dedupe. If any of the hosts fail and the remains are unable to meet the policy requirements, you may end up with data level or data loss. It's recommended that even temporarily add a host to the cluster if you're low on capacity, time that you enable dedupe, so that we don't have to choose the option of allow reduced redundancy. What is that? Instead of vacating the disk group, it's going just to destroy it without copying the data off it to any of the other nodes or the disk groups. This? Okay. All right. So I talked about. Okay, now let's talk about fault domain. vSAN 6.5 introduces the concept of fault domain. Fault is when a fault happens, how do you treat this fault? Let's say that I have hosts here, and these hosts are on 3 racks, 2 per rack. If the host fails, I risk that I have components of one mirror on the 2 hosts in the rack. It means that when I lose that rack, I lose that object. How doors not string these objects on these 2 hosts that are on the same rack, or any 2 hosts on the same rack. If I find both hosts as being in one fault domain, I will never store replica of the same object, of a given object, on hosts in that same domain. So I'm going to have one replica in any of these 2 hosts, and the other replica will be on any of the other 2 hosts on the other 2 racks. Compare that with 2 plus, and give a name of the fault domain. Let's call it rack 1. Select the hosts that are in that rack, and OK. domain. Starting here with a cluster that has components distributed on it, either this host I'm selecting has of an object, read one object or not. I can tell which disk has what. In vSAN 5, now the ability to look at the individual disks. Monitor, vSAN, and then physical disks. You would see that you have this host. I see that this host I have these objects. This is a RAID 6 drive. Swap object for a running virtual machine. That book VM1. And I have object here. This is the vSAN stats DB object. Want to know that? This is a database that vSAN check utilizes to monitor the stats, not object, the performance, to monitor the stats of performance. In these, on 5.5, we create a database on VC, where we have subbases. In 6.0, we create on vSAN, where all can access it. The performance data or metrics are written to it by all nodes that are tracking the performance. So you can display the aggregates of the performance from all. Do it in a second. But here, this is the easy way to identify. Even if I want to have a disk that I want to decommission, I select one disk, I see the empty. Oh, that's hard disk 4 is on that disk, and the vSAN DB stat DB object. The third disk is a that in this host, I own this disk with data on it. This doesn't have data. Now it has a swap object, and this doesn't have data. If I'm going to decommission the disk, replicate the data of the disk in the group or another disk group. How is that? Configure, disk management, a disk group, take the disk, and you want it. Sorry, an option here it says remove selected disk from this group. It's all action, and the options there. Remove disk from this group. Which disk in the actual host that you're planning to remove, if you know which one you want to remove, you want to make sure that you're going to remove the right one, you can turn indicator LED on, and you go to host and look at the flashing LED. So then the other disk. So you know that that's the disk that you highlighted. If it's the wrong disk, then back here and turn off the LED, and then click the other disk and get the correct disk flashing. And this, you know that you're removing the correct disk. So next, remove disk from this group. So let's select that second disk here, and it's removed. It says not available while when dedupe is enabled cluster. It means that you're going to have to disable dedupe first before you decommission one disk. If you do, then I can decommission the whole disk group. Selecting this one here, and so remove this group. Here's the option you do. You want to do data migration or instability on the data migration. familiar to you is on a maintenance mode, which is set. If I go to this host here, and maintenance mode, maintenance mode, doing set of choices, addition to, but this is the beta version. The pre-version would have a down menu. Let me show you the this one here. We are in maintenance mode. We have the down menu here. We ensure accessibility, full data migration, or no data migration. It means that it's going to check which objects are on this host, and it will check the remaining objects on the other host. And if remaining objects are sufficient to maintain accessibility to the object, it means that it's majority on the remaining hosts. It means you can put this host in maintenance mode. Otherwise, you would have full data migration, where you empty that host completely from any data. And you do this if you're going to decommission the host permanently. Usability, if you're going to keep the host down for less than 60 minutes, and the power up time and boot time. The object that is a component. After minutes, we trigger the process of rippling this object from the surviving components to meet the usage policy requirements. Unless you're doing full data migration, we're going to migrate the data immediately. The process of copying from that to the other, or going to remove the disk group. You get similar choices here. So the additional option available in the maintenance mode compared to this group, or remove this group, is this checkbox that says move powered off and suspended virtual machines to other hosts. And go to this one here. Your choices are here with the but within this beta is that now we give you the amount of data that will be moved compared to this one here. If I again. It just gives you the choices. It doesn't give you an estimate. The data that's going to be moved, you can anticipate the duration of time it takes for it to complete the process before it proceeds with the process of removing that disk group. To the fault. So like fault domain, you can create as many means as you want, up to maximum number of whole cluster, which we use for hosts. But it does sense that you create host per fault domain because that is the default anyways. Each host is its own fault domain, even though we don't state that. So fault domains, again, are to separate hosts in separate physical placement to be treated as one logical entity. Where we distribute the objects, we will never place two objects onto the same domain. We have separate them onto each separate fault domains. Clusters is an extension of a fault domain where you have two fault domains, one per site. An example here in the slide let's use this one as an example, but disregard the disaster recovery part at this point. So this is one site. This is second site. You create a cluster. Like this site is one fault domain. This site is the second fault domain. And it has to exist on third site. You want to make sure that if site fails, they will exist. Because with witness and insight, you will never have a majority. And the witness is the one that's added to the surviving sites to give it a majority. So you can have a witness installed in a third site or in a cloud. Where one site is one fault domain, the other site is a second fault domain, and the witness gets added at the time you configure this cluster. The cluster is a scaled down version of the metro cluster or edge cluster. So let me go through this configuration with these two nodes here. I created a cluster, but I haven't configured vSAN on it yet. And we added the two nodes to it as the remote, office, branch office. We configure here. I said configure to host vSAN cluster. Next, by that each host in the cluster has a VM port, VM kernel port with an enabled, vSAN enabled. And next, it will show the available disks on both nodes, and it will group them based on their capacity and the type. And here, it's an all-flash configuration because I have flash here and flash here. So I expand one here. I'll see that I have these three capacity tiers and capacity tiers, so total 6. If it's right, you will see what they're on. Host 11. And here, I have one on each host. How did the wizard mention of which one to choose for cache and which one for capacity? It's based on size. Cache used for cache, and the larger size is more suitable for capacity. So in this configuration, by the way, vSAN in the past, when you in 6.5 and earlier, when you enable vSAN, it gives you the choice to select the disk mode. Is it manual? Is it automatic? I always do it manual, so I have a choice of where the disk groups, where to allocate the disk to each disk group. Go next. Now select the witness host. Oh, I forgot to do that. Here, create a witness host. Since you have multiple remote office branch offices, it is able to create a physical host for of those remote sites. VMware created a virtual machine, a virtual appliance. It's only dedicated to be a witness appliance. So specially used non-general purpose vSAN, ESX configuration. It's an ESX that's crippled to only support witness objects, and you cannot create virtual machines on it. So we did a virtual appliance from the download site and go to, we're going to host your witnesses. So for example, in this diagram, consider that this is your management site, and these are your two remote sites. I have a slide for Robo. See. This nodes in a site, a management site. So I will store the appliance on my management site. I can have all of my witness appliances in this management site. So what I can deploy the virtual appliance, be available on the management site as an ESXi host. So here's my management cluster on my management site. I'm going to go to that host or on the cluster, and then deploy OVF from template. And we have downloaded the file, and file. This is OVA file, and open and similar to the VF. And you give it here. Witness 2, and to go. Cluster here is under my book data center. Here, the host under the management cluster. You should put it on a vSAN cluster that is going to be a witness for, but it's egg or hen anyway. So here, I place it on this host that's in my management cluster. And after it validates, there was everything is fine. It's going to give you the choice now. It says if you're going to deploy it as division, the script is unknown, it's going to be thick provision, it's going to need 1.4 terabytes. I will prefer to use provisions because I'm going to store many of those on my management cluster data store. Accept, and then next you choose the size of that. Depending on how many VMs is going to be created on a vSAN Robo cluster, you set your size. Because I didn't have space, I'm going to use it for tiny, but you can medium or depending on your capacity. I doubt a Robo site is going to have 500 VMs. It's between 10 and 500, you select medium. It's more than 500, very doubtful, you select a large. So here the 2 CPUs and 8 gigs of RAM versus 2 CPUs and 16 gigs of RAM. And next, where you want to store it on that management cluster, select the data store, and you would select your provisioning. Make sure to select 10 provision if you want to save on this space. The witness components are very small. They don't space, so they're not going to grow the capacity that much, so you will better save on this space. 10 provision. And then network. The idea that in the Robo site, you would and connecting the two nodes for network, and you have a network that connects the two nodes to the witness. And these are typically two different networks. In CL5, you can connect both nodes with direct connect without a switch. So you have fine on both nodes that network point pointing to using the uplinks to those NICs that are used for the direct connect. And these that are used for the uplinks to the WIT network, or the actual corporate network, in this example, it needs to be a separate port group. So here, I have that because I'm in a lab environment. You would have something called corporate network, for example, that's you to the witness. So that's the witness for connected to the network. And the management network, you need to select the management network. So management network is what's going to be used for end node traffic. Then you go next, password for the root account on that virtual ESXi host. Update it. And since once validated, you can click on next. And when you click on finish, it will start deploying. It takes to deploy, in my environment, usually about a few seconds. So it's faster the time it takes to go through the wizard. Anytime you lose that node, just alert the cluster and reconfigure it and add a different node that you replace instead of the one that you lost. If you lose it, it takes you a few minutes. So there's no need to worry about availability of that witness node. You can place it in a very short period of time. I deployed one here. That's called witness one. Process again of the robot cluster. I'm going to configure 2 node vSAN cluster, and then here are my networks. So this is where I picked my vSAN network, which is the network that's going to 2 nodes. The width is automatically known by the definition of adding the actual witness to the cluster. So here, and if say not claim, you can select claim for select this for cached here. Look, I already have running. Let me here and refresh. Okay, now we detected the correct categorization of cache here and capacity here. I come to the next step where I pick my witness. So put my witness in my management cluster. So you know, to do that, you need to configure the witness with these. If you use static IP addressing, it defaults to dynamic IP addressing, DHCP. So install this here and take you through this process. So, for appliance that's running the witness, you need to first configure it. fun. Okay, well. Okay, go configure management network and IP for configuration. And use static IP addressing, then you exit static IP address. Configuration. And then you need to go to deconfiguration. And I'm going to use the following DNS servers. In my environment, I have a DNS server at this address. And use IPv6. Have entered too soon here. Enter my host name. Where is my DNS? Here's my DNS, and I named it witness. So it's called witness.booklocal. And since I'm on IPv6, I'm going to go ahead and disable IPv6. I went to which enabled while I'm not going to use it. So I prefer not to. Then it's done. Escape. You get that house. Less than a minute or so to go. While it's doing that, let me here and I can answer questions while this is doing that. No. Okay, let me see what else I wanted to show you quickly while this is loading. Okay. Again, this witness can be run on a data center in your management site or in a cloud. If you have vCloud Air or other VMware-based cloud, you can use appliance on that. And quick requirements between the witness and the site is about 1 meg per second bandwidth and 5 millisecond latency around it as a time. Between the nodes with the connect, you're going to get, you have minimum 1 megabit, but better have 10 gig, 10 megabit per second. Sorry, gig E versus 10 gig E, sorry, not 1 meg. I connect with 6.5. Before that, you have to use a switch. So this node is booted. I can go back here and start the configuration. Refreshing here just to avoid any old information. Get my witness. There. one, so I need to find it in wrong DC. So any witness move like this. Have to be, no, I can integrate it here. No, I have to pop first. The idea that I needed to have it here, so I'm going to see it. Let me try it then. I should host that's called witness host, a VM that I created with the name witness VM. Oh, it off, sorry. Put it back on. While this loading, the idea is that when you enable the robo cluster, you'll be able to find that witness lines that you okay, I forgot one more thing. I need to go to this witness. This is run as a VM, so I mount it as a host in this data center. So add a host. Forget here, very important step. And put the name. Make sure it's booted. Okay. And next, and root, user password. So I'm going to use the eval for now. The witness appliance is supposed to ship with its own license, but the version that I downloaded is a beta version. That's an issue with that. So no, you shouldn't use up one of your own licenses for vSphere. So now that I should be able to go here and configure the cluster. And this. When you said it's going to do a validation that it has the correct resources in a witness node, if in the process of having to reconfigure the cluster, you can use the same witness node. Because here this has the adapter with vSAN traffic not enabled on a select host. So go here. I need to figure normally the witness appliance ships with two prefigured VMK ports and one with vSAN, but this one I've had a problem with. So I'm going to share the management with the virtual SAN for now, for the sake of time. Seated, compatible seated. Now see, and this is where we're going to select the and capacity, and automatically detects that the appliance pre-configured with one flash and one HDD. It's not really a flash; it's just a virtual disk, but it's flagged, it's tagged as a flash disk. Same way you do in all nested lab environments. It doesn't have to be all flash for the witness appliance to support all flash cluster. And review and click OK. We in process here, progress. Okay, it happens that this host that I added here, it was in somewhere else, but deleted the metadata on it and moved it to this RoboClub. So reference to that fault domain for that host, but normally have the and the site. Third site is the primary fault domain. We have a split brain, fault domain, while the connection to both the connection to the witness, the preferred fault domain is the one that wins. Okay, so this finished configuration here. I'm not sure there's a dial tone on the line. Okay, it's just 2 minutes left. So this is your RoboCluster created. You see that it sets each node in its own fault, and witness defined on the top there. So when you look at the stretch cluster, you would have two separate fault domains and the witness nodes stated on the top. The preferred fault domain is called preferred. By selecting the domain and on this icon to select as a fault. But it will be confusing if it's called preferred and it's not. So I prefer to change the name. Instead of preferred, let's call it example. So you edit and the keys. you want to switch to West 1, the preferred, select this option there and click yes. So this is a full cluster. You would have multiple nodes here and nodes here. They need to be nodes on each site. Configured. Robo a stretch cluster that lately in the site and the site millisecond, not slower. Any questions?
No.
There are areas that I haven't covered that you would like to see. We have about 5 minutes left.
Okay.
Much more to cover, but very, very little time. So final, part and thought is the typical design is that you would have your management cluster separate from your data cluster, and if you're going to have a robo site, you would have your witness data center separate from can be part of your management cluster or somewhere else. And if it is, then you need to have it in a separate site, but that cannot be on any of the sites in the or the cluster. Witness for the stretch cluster and for robo cluster, you use the witness appliance, which is a lot more economical, as it is an nested appliance. It doesn't use up too much hardware, and freely it's supposed to ship with its own license, so it doesn't use up any of your licenses as well. And vSAN 6.5 license now allows you to have I'm sure about dedupe. I think dedupe requires the license. That's Enterprise Plus. I'm not an expert on licensing, so sorry for that. And again, with the sizing guidelines, the 10% or 10 to 1 cache to capacity, that applies to the hybrid. For all flash, since we're using the capacity here for read cache as well, the cache is used for write buffer. All of it is used for write buffer, and what's written on it would be read for cache, and what's not on it would be read from the capacity tier directly. So it's more economical and better performance. Okay, if there are no more questions or no questions, I can go ahead and pause the ring.